come into my bedroom, come in at night. Y'all take your bow away, I'm gonna skin it alive. Where, hold it now, love, y'all gonna get cut. Where, hold it down, love, didn't know for what.
right, so welcome back. I hate this room. We have to use it. I hate it because we've got the screen right behind me. So if I'm ever covering something up, please let me know and I'll try to move. But otherwise, the main section for this course is right beforehand, so I have to run over here and wouldn't be able to make it to another building entirely. Again, welcome back. This is CSCE 156H. That's Computer Science 2, the honors section for this course. As always, as last semester, I'll be live streaming, so everything is available on YouTube. Attendance is not taken in lecture. It is taken in lab, but not graded. We'll talk about that in a moment. But otherwise, I'm going to give a course introduction pretty quick, since most of you know how we operate already. And then we'll get started with Python. So at the end of Computer Science 1, hopefully what you have picked up by then is that you should be able to approach a reasonably complex problem and design a top-down solution. That is, you take the problem and you break it up into smaller and smaller chunks until it's one line of code or a function in a standard library that you can bring to solve that one piece. And then program it in a high-level programming language. The key realizations that you should have coming out of CS1 are that you're still the problem solver. Humans are still the problem solvers. Computers are dumb and they do exactly what they're told. Programs only automate solutions. Computers are good at processing large amounts of data very, very quickly. Humans are not good at that. Computers are not good at problem solving. Humans are good at that. Right? Even the bleeding edge AI, ChatGPT or whatever, all they can do is regurgitate what they've been trained on. Right? By the time that you've sorted something, a complicated idea out into little steps that even a stupid machine can deal with, you've certainly learned something about it yourself. That's the essence of problem solving. By the end of Computer Science 2, you should approach it from the opposite direction. You should be able to approach a reasonably complex problem and ask design questions first. What objects should I create and design in order to model this problem? How do those entities, those objects, interact with each other to solve the problem? And what data structures can I pull off the shelf to solve that problem very easily with a minimum amount of code, minimum amount of effort? Exemplified at the end of this course is a data structure called a heap. If I took a bunch of stuff and threw it into this data structure and then pulled it all out, magically it would be sorted, right? And that is the essence of data structures. That I can take this smart data structure and put in dumb code and just put stuff in, take stuff out, and it sorts it for me. That's called heap sort. Right? And that is the mantra of this course. A quote by Eric S. Raymond here. Smart data structures and dumb code are a lot better than the other way around. You probably may remember insertion sort or selection sort or quick sort. All very, very clever code, smart code. Right? But then I've got this thing over here called a heap, and I can have a dumb code. Just put stuff in and take stuff out, and I've solved the problem the same way and just as efficiently. So smart data structures are way better way to go. Okay. For the first 3 weeks, we will be covering Python, not Java. Java is in the main section. So if you need a refresher on Java, I would suggest that you either attend the main section or watch the live streams of the main section or watch the videos of the main section. But otherwise, in this course, we'll cover Python as our now third programming language. You had C, you had Java, now we'll do Python. You might have done Python before. From my experience, the Python that high schools cover is not really the Python. They don't really cover it in the Pythonic way. I do, right? When in Rome, act as the Romans. When in Python, do it the Pythonic way, as the saying goes. So the next 3 weeks, we'll then go back to Java because we'll be discussing object-oriented programming. Python does have classes, but it is not an object-oriented programming language. It has elements of object-oriented programming, but it is not truly an object-oriented programming language. Then we'll learn a fourth programming language, SQL. That's for querying databases. We'll do database design in SQL, database connectivity, and then we'll pivot to data structures and algorithms. List-based data structures, algorithm analysis, stacks and queues, and binary tree-based data structures. Right? Binary search trees and heaps at the end. The assessment for this course is based on two things, labs and assignments. No quizzes, no exams. In CS1, we did have exams and a final. We don't have that here in CS2. Labs are based on completion. right? It's about 20% of your grade. There are 14 of them. I think we cut out maybe we cut out the recursion one. I forget which one, but there's one in there that we don't do. Every one of them will be the same. There's some starter code on GitHub that you check out. You finish the code. You hand it in through a WebGrader, which is different than CodePost. We're not using code. We are going to be using CodePost for assessment and grading, but we're not going to be using that for correctness like we did last semester. That's because CodePost can't handle database based stuff, right? Unfortunately. Attendance points is 5 points. That's the main section, by the way. We will take attendance. We will not grade attendance in the honor section. We're of the assumption that the honor section is self-disciplined enough to know, do I need to attend the lab or not? Can I get this done on my own, right? But otherwise, we give you a whole bunch of JUnit test cases. You hit a button, and if it works, and it's 20 out of 20. If one of those test cases fails, it's going to be a 0 out of 20. So make sure to go back, give yourself enough time, fix those issues. They all pass. Turn it in as many times as you want. You can actually run the JUnit test directly from Eclipse, though. Right? Don't worry about the attendance points. Again, we take attendance just for record keeping, but we're not going to grade on it. 80% of your grade is based on assignments, and there are 8 assignments plus a design document. We start with assignment 0. Why do we start with 0, by the way? We're all computer scientists, right? Indexing, exactly. The proper way of counting. You always start at 0. In fact, when I occasionally do 235, we talk about the natural numbers, right? This big N. And in grade school or K through 12 education, they always say that, oh, the natural numbers start at 1. No, they don't. You need 0 because you need an additive identity. If you don't have an additive identity, you only have like a semi-group you don't even have a semi-group with an additive identity. So it's improper math. But that's math stuff. Always start at 0. Right? The first one is 3 basic programs in Java. Now, if you are deficient in Java, you can complete them in Java if you want to. The first 3 labs, if you're deficient in Java and think that you need a refresher, you can do those 3 labs in Java. We encourage you, though, to do them in Python. These 3 basic programs are programs that you've done before in CS1. So maybe I should not say that you can't do them in Java because you've done them in Java, maybe. You should probably do them in Python. 90% of you will do it. 99% of you will do them in Python. But it's going to be individual, no partners, no collaboration on those. We just simply need to make sure that you are prepared for this course. Right? Otherwise, after that, all of your assignments are project-based. Each one of these is a phase that you are designing and implementing a project, and each one of those phases will build on the previous phase. So in the first phase, you design your objects and do some EDI, which is electronic data interchange. You take a bunch of CSV files and convert them over to JSON files using a library, right? You should use a library. We show you how to do that. Then you design the application and you test it. Then you design the database to support the application. Then you implement the code to load up data from the database. Then you write code to persist or save stuff to the database. Then you design a list-based data structure and integrate it into your project. Each one of these phases builds on each other. Right? The first assignment 0 here is independent, but each one of these phases builds on each other. So if you have a bad design in phase 1, you're going to go back and fix it because you need it for phase 2. Right? Each one of those phases is accompanied with a design document. A design document is a living document that is maintained throughout the semester. In the first draft of this design document, you'll be talking about the first. You'll give some background on the client. I think what is it? It's a construction management company that you're writing software for. It's not a real one, right? Actually, I didn't make it up. It's from a TV show. Very Good Building. Is it Very Good Builders or something like that? I forget what it was. Anyway, you'll be working for Ron Swanson. And you're writing this application to support their sales system. But each week that something is due, the week prior to that, that's when you submit your design document. Because you're going to give us an outline or a sketch of what you're going to do, a sketch of your design, and we're going to critique it. We're going to say, that's good, that's bad, and here's why. Or this is okay, but have you thought about that, right? And if you give us a good design document that we can actually critique and give you good feedback on, then that's going to improve for everything for your actual submission. Right? The second reason that we do this is because we want you to get exposure to technical writing. Right? This is an IEEE like 1036 standard or something like that. We give you some templates. We give you a Word template or a LaTeX template. Choose which one that you want to do. Right? In week 4, to talk about technical writing, I'm going to invite somebody from the Writing Center to come in, and we're going to talk about how to go about technical writing. It's not a 5-paragraph essay. It's not creative writing, right? It's not embellishment. It's basically just the facts, right? In fact, we don't want to see a design document more than 10 pages, and that's with cover page and bibliography and contents, right? You're going to try to write as little as possible to get the point across, okay? In fact, when you'll be required to submit a UML diagram and an ER diagram. Most of this design document is going to be diagrams, right? The writing is going to justify those diagrams. Everyone is highly encouraged to work in pairs. For labs, you can for everything you can work alone if you really want to, but for labs, work with whomever you want. Right? For the project 1 through again 0, no partners, no collaboration. For the project 1 through 7, you can team up, and if you're going to team up, you need to do so in Canvas. Sorry, I can't highlight that. Right? Pair up in Canvas. You'll turn in 1 copy for both of you. Right? That should be an equal amount of work. Don't just say, I'll do the first phase and you do the second phase. You can split up work to some extent, but everything both of your eyes should be on every aspect of the code, right? If your partner does some code and it checks it into your Git repo, you should be reviewing that code because you're going to be using that code in whatever you're doing. It's easy to bounce ideas off of each other. It's much better to whiteboard something when you've got somebody there critiquing what you're doing. Like, no, I don't like that. Or you can have healthy debates on the design. Right? It's development of those soft skills. Right? When you're whiteboarding stuff, then you're doing communication. Right? You're improving your communication. You're improving your teamwork. And eventually, it's not really an issue for the honors section, but eventually you may have to have some conflict resolution. Your partner is not pulling their weight. They're not contributing enough. Right? You have to learn how to set expectations that we're going to meet every Tuesday at this time, right? And then they consistently don't come to those times. You need to resolve those conflicts. And ultimately, if it's a bad partnership, maybe it needs to be dissolved, right? And you're going to have those hard conversations. Having the option in this course is probably the only time you're going to have that option in your life. Right? When you get into the upper level courses, your teams will be dictated to you. When you're doing your senior design projects, you'll have very little choice in who you're working with. When you're in an actual job, if the person sitting next to you is a terrible employee, there's not much you can do about it. There is something that you can do about it here now, though. So take advantage of that opportunity to learn the conflict resolution methods. Right? Again, partners can mooch, flake out, disappear. Not really an issue with the honors section. But choosing to work in pairs means that you're taking on more of a responsibility than if you worked alone. It means that you're now responsible for yourself and your partner. Right? Use Git. Please use Git. Don't hand files back and forth with a thumb drive or email or something like that. Don't undermine the learning process of your partner, and make sure that you pair up in Canvas. Use of AI tools is prohibited. Start early, right? Have a good thought out design on paper before you even start coding. Design your test cases before you start coding to understand the problem better, et cetera, et cetera. Right? So all the good things here. Something that you should be aware of at this point, since because you're doing a larger project, is technical debt. If you don't have time to do it right the first time, you're going to have to find time to do it over. Right? Meaning that if you don't do it right the first time, you're taking out a loan. Right? It's actually what's called a blind open option. I forget what it's called in trading, where basically you have no idea how much you're going to pay in the future. Right? I'll just go ahead and throw something together really quick and it works, right? But it's terribly designed. That means that in the next phase, you're going to be spending hours upon hours fixing it, refactoring it, debugging it, because now it doesn't work. Right? Whereas if you had invested 1 hour up front in a well thought out design, that's going to save you 5 hours down the line. Right? So look at your time as an asset. You can invest it, or You can borrow it. That's a loan. What happens with loans, though? If I borrow $1,000, I need to pay back $1,000, but what else do I need to pay? Interest, right? So is it an asset or is it a liability? Your choice. Right? A whole bunch of resources here. What I want to start out with, though, is a Gantt chart. Everybody in here is probably pretty much self-organized, self-determined, self-motivated. But this is a Gantt chart that I provide just in case you want something to keep track of your progress. There are a whole bunch of ways of doing this. There are like burn down charts and Trello boards and stuff like that. This one dates back well over 100 years. The idea is that you have something that's due on a particular date. Your first assignment is due on February 7th. Then you work back from that, right? I know that I'm going to have to read the document at some point, right? I know that I'm going to have to set up my Eclipse or set up my environment and outline my programs. I know that I'm going to have to design my test cases. I know that I'm going to have to write the code. I know that I'm going to have to debug the code or refactor the code or clean up the code. And finally, submit it to the grader. Once you've mapped out the things that you have to do, you start estimating how many days each one is going to take. And then you work backwards. It's going to take me 2 days to submit it and test it with a grader. It's not going to take that long in reality, but I'm putting 2 days there because what if it fails in the web grader, right? Then I need to go back and fix it. I'm giving myself a buffer of 2 days to do that. Note here that the weekends are grayed out. I don't expect working on weekends. 3 days to refactor it and debug it. Right? 2 days for that first draft, et cetera, et cetera. Right? As you work along, if you choose to use the Gantt chart, you can mark things down as complete. I'm 100% done reading that document. But well, you know what? I skimmed it the first time, so I'm probably going to have to come back to that at some point, and it's only 50% done. See the color highlighting, right? Hopefully you're done with Lab 1 because it is due at the end of the day here, 100%, right? Gray that out. The current day is highlighted in red here. This gives me an idea of am I ahead, am I behind, or am I right on track? Right? I have mapped out the first 3 assignments, not the last 3, because by the time you get to the last 4 or whatever it is, right, you're going to have a better idea of how many days each one of these things is going to take. You're going to have a better idea of how you work. Right? No, that's actually going to take me way longer than 1 day. So I'm going to bump that back to the 19th. There we go. Right? It shifts everything over. 19th and then 2/21. Give myself 3 days for that. Right? Everything gets updated automatically. Okay. I did not write this Excel file. I stole it from somebody else, but I did adapt it for this course. Right? That's a tool if you need to determine am I on track or not. I will be following the Gantt chart on posts on CampusWire. Right? So we used this last semester. I don't have it up yet, but I will have a pinned post for each one of these assignments. And I'll update it on a daily or semi-daily basis on where you should be by now. And are you ahead or are you behind? Okay. Let's see. No, we're not there yet, but stay alive, please. There we go. Here's Canvas, but let's go to the proper course here. There we go. Everything is mapped out already. Everything is already released. Getting help. There I am, along with, So we're only listing the LAs, the 3 LAs, 2 LAs, and then 1 course leader here for this section. You're probably all familiar with Emmanuel and Parker and Tadapali. But feel free to come to any of the other help hours. Here's our help hour grid. My help hours looks like Mondays and Wednesdays. Right? Otherwise, pretty much covered throughout the entire week at some point. Everything has a Cinderella Friday due date, meaning that it's due at midnight. And so be cognizant of those final help hours on Fridays. Emmanuel is there, and another person also covers until 4:30. But that's your last opportunity to get help. Right? So in other words, get help early, because I can tell you pretty much by history that Friday, Avery 15 is full of people that have waited to the last minute. Right? And you probably won't be able to get help that day if you're in that same bucket. Right? But otherwise, everything is posted down here. There's more information about the Learning Assistant program. There's our course FAQ, course info, and other resources. But otherwise, pretty much the same structure as CS1. Every week, I post videos of the recordings of the live streams. You've got your labs, and you've got your required reading and or required watching each week. I do not have a pre-prepared video on Java, or on Python. I do on Java. So if you're deficient in Java, you can watch this 13 video series in Java. Instead, we'll cover Python in course. 2 things you have to do this week. Lab 1 due today by midnight. And then a pre-course survey here by Friday midnight. Again, Cinderella due dates on everything. Cinderella refers to midnight. Everything turns back into a pumpkin, so everything's due at midnight. Right? Otherwise, there's that first assignment that is due on February 7th. Right? There's the starter code. There's some starter code right there, but otherwise, here's the handout. Right? It'll look really familiar. 2 closest points among 3. Right? Did you do that? I was on your first exam last semester. This one was on your second exam last semester, right? Where you are doing a bunch of elevation gain calculations and then map conversions from meters to feet. Right? And then finally, running data. Does that look familiar? That was your final, right? So you've all done this in Java and or C, right? Now you need to do it in Python. Right? So you already understand the problems. By the way, there is another report that we cut from the exam just because it was getting too long. But you're given 2 sets of data, and you have to find anomalies between them. So missing in one or the other, and then things that are that are inconsistent here. And the full instructions are in there. But otherwise, the full instructions are there along with a full rubric. Right? Each one will have a full rubric on what to do and what not to do. Right? Questions so far? Yeah.
So it's not like the 155H where we have to do like the Java and Python?
No. So I don't know how you would assess how much more work you did in 155H. Maybe 40%, let's say that. In this course, you're going to be maybe doing, because of the honor section, maybe 10 to 15% more. And by more, what I mean is in the assignments, let's see, I'll show you here. They're going to be extra credit bonus items, right? But for this course, they're required. So for example, you're going to convert those CSV files to XML and JSON. In the main section, they have to do one or the other. If they do both, then they get 10 points bonus. Here, you need to do it both, period. Not only that, but you have to submit your test cases 1 week prior along with your design document. So there is extra work. I would say maybe it's 10, 15% extra, not maybe 40% extra in like 155H. Right? For those first 3 labs, there are Java versions and there are Python versions. You only have to do one. Right? For the first assignment, there are Java versions and Python versions. You only have to do one. And again, you should do the Python version because you all know C and Java already. But if you really, really need a brush up on Java, then so be it. Do it in Java. Right? Okay. All right. I think that's pretty much it. Right. Otherwise, we'll be reviewing some of this stuff as we go along. So how many people already know Python? A little bit or a lot or whatever. Okay, good. Probably might now be your first programming language that you see in high school or some code camp or something like that. It is older than Java, actually. It goes back to 89, 91. Guido van Rossum wrote it. Right? It's an interpreted language, meaning that it's a scripting language. You don't compile, like C, you compile it and it runs on that machine and only that machine. Java, you compile it to Java bytecode and it'll run on Johnny Java virtual machine. Nope, here it does have what's called a JIT, just-in-time compiler, but for the most part, it's an interpreted language. There is no compiler. Instead, you just start running it. If there's a syntax error, it runs up to that point in the syntax error and then it dies. Right? So a program can run half or 10% or something before some fatal error is there. It is dynamically typed. Unlike C and Java where you have to declare a variable, this is an integer variable and it is only an integer variable, right? It's dynamically typed. You can take this variable x and if you assign 42 to it, it's an integer. If you assign 42.5 to it, now it magically becomes a double. If you assign a string to it, now it magically becomes a string. Right? Don't think that that's a good thing. Right? Dynamically typed languages have huge headaches because of this. Imagine writing a function and having a certain expectation that the inputs are integers. Anybody can call your function and give you anything, whatever the hell they want, right? And now how do you handle that, right? So it's not a good thing necessarily. It supports integers, floats, and doubles. They're the same thing. There is no single precision floating point number in Python. And strings. And by the way, integers, we're only going to talk about Python 3, by the way. Python 2 is dead, right? Python 3 is where it's at. And in Python 3, as of like 3.6 or something, all integers are arbitrary precision integers. In other words, you create an integer, you can make it as big as you want, you can make it as small as you want. White space matters, icky, right? Why? Because there's this great video on that makes fun of Python. He's got an entire series of videos that makes fun of each language. But he's got this great video that makes fun of Python. He's like a Python, fanboy. And he goes, it's great because all you need to do is hold up a ruler to your screen to find out if the code belongs to the same spot, right? And so white space matters. 2 spaces are not the same thing as 4 spaces, are not the same thing as 1 tab, right? You need to make sure that they're all the same, right? And for that reason, it can be kind of confusing because what if I did a tab on this line and then 4 spaces on this line? It's gonna donk out and not understand that, right? Do things in the Pythonic way, and I'll cover that as we go along. Everything is going to be lower underscore casing. Even I have to get out of this habit, right? So if I'm not doing this properly, yell at me and I'll fix it, right? 4 spaces for indentation. Right? There's a nice little tool here called Pylint, right, that you can use to determine do I have good style or not. To understand this, let's just go ahead and get started. Where's my CS50 IDE here? There we go. I recommend that you use the CS50 IDE from last year, that we used last year. It's a full environment that has Python installed already. You don't really need to do anything. And you do have sudo access so that you can install Python packages if you need to. For example, Pylint doesn't come with this. You can install it though. I'll show you how in a second here. Let's go ahead and create our first Python script. I'm going to call it hello world.py. .py because short for Python. Right? Underscore because that's the Pythonic way. Okay. I'm just going to go ahead and print out hello world. Print hello world. There we go. There. That's all it is. Right? Now this is not the ideal way of doing it, but it is a way of doing it. How do I execute this? Well, I need to be in the correct, we're in CS1. Let's go into CS2, my lecture stuff, and there's hello world.py. You run the Python interpreter, which is Python, right? And hello world.py. Right? You feed it in and say, I want to run that script, and it does it for you. Did I explicitly put in that inline character there? Nope. Print does it for you automatically. There is no printf like in C. Right? There is only print. Okay. We'll talk about how to get printf-like behavior using what are called f strings, probably by next time. Yeah, we've got plenty of time, maybe today. But otherwise, there's my first hello world script. Now, the Pythonic way of doing this probably would be to use single quotes. Double quotes, single quotes, no difference. Right? There is no single char character. If I did something like initial is equal to C, that's actually a string. It's just a string of length 1. Right? Also in Python, you can, but should not, include semicolons. The interpreter will ignore them. So if you want to have a C flavor, fine. But when in Rome, we do things like as the Romans do. When in Python, we do it the Pythonic way. No semicolons there. Right? Otherwise, that's a full string right there. Right? There, that's a little bit better. So what else do we need here with a basic Hello World program? Documentation. All right, I'm going to go ahead and try to use some documentation like this. Right? And here's my author. I'll just put in my name for a second here. All right, let's go ahead and try this. Doesn't work. C style syntax does not work in Python because Python is not C. Right? So this multi-line comment is not how we do it. Instead, what we do is 3 double quotes followed by 3 other double quotes. This is not really a comment. This is what's called a multi-line string. Chris Burke, 2025-01, and today is the 21st, and prints hello world to the standard output. Author documentation includes your name, the date, and the purpose of the program. That's perfect. Right? This is the Pythonic way. This is how you should document things with these multi-line doc strings. Okay. Later on, you can do it down here. You usually do it for functions, though, right? This is also a string, not a comment, but because it is not assigned to a variable, it acts as a comment. Right? It's like a string that you create, but is not actually used and doesn't actually do anything. So in other words, it acts like a comment. Right? Actual comments would be something like this. Hashtag. Right? Hash prints hello world to the standard output. I can increase the size here. Right? That's too much. And I'm running out of real estate. There we go. Is that better? Folks in the back? There we go. All right. That's a single line comments. Line comments. Right? And if you want to, you can have a whole bunch of them like this, back to back to back. Now, wait a second. Is that a good comment? No, why? We had a term for that. What do we call that? Cruft. Right? Garbage that should not be there in your final submission. If you want to outline your program, right? Like step 1, read in input. Step 2, compute something. Step 3, do something else. That's fine. But those don't belong in your final submission. Okay? Now, I don't see a main here. If this were Java, I would have a public static void main, string args. And if this were C, I would have int main, int argc, char star argv, right? I don't see that here. Right? You actually do have it, though. Let me show, yeah, here it is. Right? So what I'm going to do is I'm going to take that functionality of printing hello world, and I'm going to put it into a function. The way that you define a function is def, short for define, and then, or let's say hello. Right? There's my function. Okay. Now, white space matters. 1, 2, 3, 4 spaces. Yes, you can tab over if you want, but your IDE is at least VS Code here, is smart enough to say you hit a tab. You probably didn't mean to. I'm going to replace that with 4 spaces. You can space over if you really want to. 2 spaces. That's not the Pythonic way. Right? 4 spaces is where it's at. 1, 2, 3, 4. Okay. There is a colon here instead of opening curly brackets, closing curly brackets. There are no curly brackets in Python. I mean, there are, but that's for maps and sets. We'll talk about that later. But not for code blocks. Okay. There's my function. Now, if I were to run this again, there's no executable code here. It doesn't do anything because I just got this function that I never actually call. Right? So what I want to do now is, well, before I go on, I should document this function. All functions require documentation. And the way that I do that in Python is not at the top of the function. Right? If this were Java, what I would do is a doc style comment right here above the function. But in Python, you put it below the function as the first thing. Okay? And by the way, this is PEP 8. Right? If you want to read all about it, it's PEP. PEP is Python something something. It's their standard for all. It's their style guide basically. Okay. All right. So let's document it. Prints hello world to the standard output. Yes, that looks like cruft to me, but the entire function looks like cruft to me. I would not put that into a function at all. Right? I'm just demonstrating syntax at this point. Okay. Now to actually call that, I need a main. So there's this weird stuff that I do. If name is equal to underscore main, then I will do say hello. There we go. That's how I make this into a main. Right. We'll talk about this later on. These underscore are what are called magic methods or magic functions. Actually, Python calls them something different. I forget. But basically, it's saying that, oh, if you ran this function, if you ran this script as the initial script, then I will treat this as a main and I will go ahead and say hello. When I go ahead and run this, now it says hello again. Right? It is not wrong, I guess, to do it just simply by just start typing whatever the hell you want, wherever you want. It's not really good organized code though, right? All right, how well did I do? Let's find out. Pylint, hello world, come on. Hello world, there we go. Oh, good. I got a score of 7.5 out of 10. What did I do wrong? There's trailing new lines, right? On line 16. All right, fine. Let's get rid of those. 100%, 10 out of 10, right? Now, sometimes, if you go with, say hello there, well, first of all, it's not going to work because I need that there. I go the old school Java way of using lower camel casing. It's perfectly fine. Syntactically, it'll run, right? Here, I'll show you that it runs. Python hello world, it still does hello world. But pylint is now complaining about this. Your function say hello doesn't conform to the snake case, also lower underscore casing naming style, invalid name. Right? This is a C warning. It's a convention warning. Sometimes you'll get W's for warnings you should not be doing this. Sometimes you'll get E's, which are for errors. And sometimes you will get S's, I think, for suggestions. Right? But in any case, undo, undo, undo. Right? Let's say that I did 2 spaces instead of 1. All right. Come on. 1, 2, 1, 2, 1, 2. There we go. And 1, 2. All right. So it'll run perfectly fine, but Pylint will complain about this. Bad indentation, found 2 spaces, I expect 4, right? It'll run, but it's a warning now, okay? Undo, undo, undo. If you really screw it up though, for example, I have 4 spaces on line 9 and 10, but then I didn't have any spaces on line 10, 11, and I have, I don't know, 2 spaces over here. I think that this will be a syntax error. It has no idea what the hell you're talking about at this point. Pylint will also probably complain about it as being inconsistent. In fact, now it's an E, error. Unindent does not match the outer indentation level. Right? Today I learned that unindent is a word, right? Or they think it's a word. So undo, 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 there we go. Now we're back to a perfect program. Pylint says it's perfect stylistically. My run says that it prints out hello world. That's perfect. Here is your first hello world program in Python. Right? All right, so Python, there we go. Darn it. How do I install? So you're probably not going to have Pylint installed by default. So it's going to be pip install Pylint, right? And it's already done, right? Oh, new release of pip is available. You can upgrade that if you want. But otherwise, pip install Pylint on CS50 if it's not already installed. Right, I'll put that down in the notes. So if not, come on, snap to, please. If not already installed, use pip install Pylint. Okay. Got 10 minutes left. We can do some other stuff, like basic operators. Right. So let me go ahead and create a new, fresh file here. I'll just call it demo.py. Right. All right, let's do some addition. Int A is equal to 42. Int B is equal to 101. Very, very C Java. Like I said, it's a dynamic programming language. You do not use int. In fact, it would not run, right? Python demo.py. It has no idea what an int is, right? As far as a keyword, okay? Once again, do we put semicolons there? You can, it'll run, right? It doesn't do anything right now, but Pylint will tell you, no, 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 no. We don't put semicolons there, okay? By the way, there are some not red herrings, but false positives, right? So unnecessary semicolon, I agree with that. Let's get rid of that. Let's get rid of that. Missing module docstring, that's telling you that there's no author header. I agree with that. I don't agree with this. And this is just a convention here. Constant A does not conform to their naming styles. it's interpreting this as a constant. That's just because later on I haven't changed it. If I say A is now equal to 24, that warning will now go away because it sees that A, yeah, oh, it happens twice now. That's stupid, right? It is certainly not a constant, right? I never intended it for it to be a constant because I am setting it there and then I'm setting it there, right? So yes, PyLint is a good tool to understand whether or not you're doing things correctly. Sometimes you need to ignore it, right? And I'm ignoring it here, right? Let's add things. C is equal to A plus B, right? No semicolon, get out of that habit, right? Now how do I print that? Print C. So what is 42 plus 101? Oops, sorry, I want to run this script. There we go. 143, right? I did not declare these variables, right? What if I had named this D instead and tried to print C? What do you think happens? I don't know either. What the hell is C, right? Okay, it's a fatal error. You're trying to see, you haven't defined that yet, right? You define D, right? Maybe that's what you mean, and there you're not going to get that suggestion. But that's what happens when you have a variable that is undefined, right? There's plus. We can go ahead and go with minus, right? There we go, negative 59. Let me go ahead and keep track of all of these, right? What other things would you want to do, by the way? Plus, minus, what else? Multiply, okay. That's the same. And 42, 42 it looks like. What else would you want to do? Divide. Now let me change these values here and ask you a question. 10 and 20, right? I'd say that that's 30. I'd say that that's negative 10. I'd say that that's 200. What would you say this coming from a C/Java background? 0? Yep. In Java, in C, it would be 0 because of integer truncation. But Python is a dynamically typed language, right? Remember that. It's dynamically typed. Things will change type. A divided by B, oh, 10 divided by 20, that's a double. I'll make that into a double for you, 0.5. And it gives you 0.5 here. Right? What if you want the other way? What if you do want that C, you want truncation? Just do it, divide twice, right? And this is why, by the way, we can't use this as, I guess, comments would be like what? Comments would be like that? No. Comment would be like that, right? And that's why we can't use that as a comment. Now what is this going to be? 10 divided by 20 with truncation is 0. Right? So this will be integer truncation division. Right? Otherwise, this is division. Automatically changes to a double. Right? Okay. What else could we do with it? Integer remainder division. You remember that one? The percent sign, good. So 10 divided by 20, what's the remainder? 20 goes into 10 0 times, and so the remainder is 10. Right? All right, what if I did this? A is now equal to hello, and B is now equal to world. Right? C is equal to A plus a space plus B. Print C. Right? What's going to happen? Hello world. In other words, this is string concatenation, right? Only when all of them are strings. What I mean by that is, let's go ahead and set A to 10, and let's go ahead and set message is equal to, A is equal to, and then I'll add in 10 here. Print message. Now if this were Java, right, it would convert 10 into a string 10 and print out A is equal to 10. Right? It's not what happens here. What do you think? Error, right? You cannot mix types with that operator. It's either addition or it's string concatenation. It is not both, right? Depending on what you're giving it. So this will be an error. Right? So what do? Pythoners. That's not what I wanted. No semicolons either. How do we do this so that it does work?
Maybe change it to 2 print statements.
Oh, okay. I could, but remember what the default is of print. It puts in that endline character for me, and I don't want that. I need to explicitly change this into a string. Right? When I do this, now it works. A is equal to 10. Here's a better way of doing it. Better output. F strings. F stands for formatted. Right? So my message is going to be, I'm going to put an F in front of it. Right? And by the way, I am making mistakes here. You should have single quotes instead of double quotes, but I'll fix that later. F tells me that this string is going to be formatted. Right? And so what I'm going to do is A is equal to curly brackets. Then inside of those curly brackets, I can put the name of a variable. Right? And let's print out this message now. That's so much better because I'm not actually calling that other function and using concatenation and all that stuff. Right? This is basically printf style formatting. And you can use some of the tricks that you're familiar with printf. For example, you want to print this as a integer. I think that this is it, darn it. No, what is it? Find, F. Sorry, F. There we go. It should be D. Oh, no percent, sorry. There we go. There we go. I want to print it as a integer. You can change that to, well, no, actually I want to print that as a floating point number, F. And now it'll print out 10.0000. Why 6, 1, 2, 3, 4, 5, 6? Why 6 zeros there? Why 6 decimals of accuracy? That's the same default as printf. I don't want 6 decimals of accuracy. I want 2 decimals of accuracy. Right? There you go. Right? F strings are the way to go. Right? If you need, I don't print, even if you don't have anything for it, message is equal to hello world. I still get in the habit of putting an F string in front of it, print message, even if it's not actually formatting anything. Unfortunately, PyLint will complain about that. You're needlessly doing something that you shouldn't be doing, right? Using an F string that does not have an interpreted value, that's one of those things I ignore, right? So again, it's okay. It's a guide. It should not rule you on PyLint. Right? What else is wrong, by the way? Oh yeah, it's interpreting all this crap as constants. You can actually shut those off, right? Here's a hint. There are no constants in Python. I don't even know why the hell it complains about this, because Python does not have constants. It has conventions. If you want to define pi, what you do is you underscore pi is equal. Actually, no, sorry. Pi is equal to 3.14159, right? But guess what? You can always change it to 3 later on, right? So you use all uppercasing for constants. That's just a signal to other programmers that this thing is a constant. Please don't change it. But you're asking, just please don't change it. Of course you can, right? All right. We'll do more on Friday. And remember, your lab is due today and your survey is due Friday.